Hey everybody, this is Larry. This is July 30th, I guess, supposedly. It's an extra bonus day for a bonus problem day or whatever. Doing an extra problem that I haven't solved before. So if you're new to, uh, if, depending on when are you watching this is a bonus problem. So I'm going to try to do it randomly. I don't know what problem this is beforehand, so I don't know. But I am going to click on the to do and then click on a pick one and hope it's not a premium solution, and then we'll see. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's random extra bonus video. And apparently, I need to get premium. Can I just do a random one that doesn't have premium? Maybe I do need to get premium. Yum, yum, yum. Alright, let's see. Uh-oh. Alright. 892. It is a easy today. Surface area of 3D shapes. Okay, so you're given an n by n grid where you have 1 by 1 cubes, and this is the height, I guess, right? Oh, wait. No, this is the tower of a V cubes. Yes. So, yeah, so that's the height, if you will. Does go any directly adjacent cubes to each other, forming several, what does that mean? 1, 2, 3, 4. Return the total surface. Okay, so we have these things, and then we have to get the surface area, and including the bottom one. Okay, so I'm just gonna set up the problem real quick before I actually, before I know what it is. Is it at least 1 by 1? Okay, so I don't have to check this. But okay, so what is the surface area, right? These things are always kind of well, the top and the bottom is just gonna be r times c twice, right? That's the top and the bottom. So that's those things will never change. So let me at least set that up first, right? Yeah, maybe I could call it top and bottom. Top, bottom area. Terrible variable name actually, but it'll be a good enough reminder for me to decompose the pieces. And then the thing after that is just the side, right? So we have and I was going to say maybe you could look at it as a side view, but that's not even sufficient, right? Because you can have like a donut hole like this one, I suppose, where it goes bottom as well. And the way that I'm visualizing here is that, okay, and I'm I don't know that I can I was gonna maybe pull up paint, but I don't even know if I could draw it that easily. But that, let's say I'm looking at one row, right? We don't need the entire two-dimensional thing. We're looking at one row, so that means that we're looking at let's start with the 1 2, just for 1 2, and then here if we're looking at box by box, the first box I'll have 1, and I'm just going to write the word 1 or number 1, and then so we see one thing, and then the second one will be 2, right? So it'll be 2, and then it goes to 0. So that means that if you think about the contour of this one, it's going to be going from 0 to 1 to 2 to 0, right? And of course, this is going to have, you see one surface, like one side, and then you see the second one of height 2, so it'll be 2, and then on the other side it'll be 0. So this is going from left to right, and the delta it's just the sum of the deltas, it seems like, is how I would maybe approach it. And maybe we'll do, I mean, this is a kind of a, I wouldn't say this, not this problem, but this row is an easy example. So let's try and challenge us a little bit, right? So let's say we have 101, what does that mean, right? We're going from 0 to 1 to 0 to 1 to 0, right? So you have 0 to 1 to 0 to 1, and then you have one side on the other one, the side that's not facing you, and then maybe I will draw this actually. Now that I think I have a better, I was actually thinking about it as I'm like looking at heads on, but now maybe I have a slightly better visualization with respect to, let's say you have one brick here. Oh, I didn't put it on the screen. Hang on. So yeah, you have one box here. You have maybe 0 box in the middle, and then 1 box here. Let's even do like a 2 box thing here. Pretend this is a good 2 box thing, and then maybe 0, right? Well, how many sides are you seeing? So the thing with these sides is that going from 0 to 1, you see it from the left side, going from left to right, you see one edge, right? One face, and then you also see one face on this side goes to 0. You see 1, and then you see 2, right? So that's where the differences between adjacent things gone. And of course, you have to make sure that you get the zeros on the edge. But I feel like this is basically it, except for, we do have one from left to right and then one from north to south or something, if you want to call it that. Yeah, instead of top and bottom. I don't know if that's a top to bottom, but yeah. So then now we can do something like, so for I in range of R, for J in range of C, we're going from left to right because we're going from each row. So let's just say left, right area. Well, let's define this as 0, but, and then here we go, I guess we can do something that starts at 1, and here we take the grid of I of 0 because that's just comparing it to 0. That's the first block, and then we also add the last block. I think that's okay. Yeah, C minus 1 from the other side, right? So then here, then we just need to, and also this is an add, kind of easy to mess up. IJ minus grid of IJ minus 1, and of course we run the absolute value of this. And then now top down, maybe this, top down is a little bit weird because I'm going like, but what we want is, let's just call this basis. Maybe that's a little bit better. And then now top down area 0 0, and we do the same thing, except for now we're going vertically, and it should be right just by symmetry in terms of if you feel like you have to prove anything. This is I wrote this a little bit awkwardly. Maybe I should have used J as the outer loop to keep it consistent, because it is easier to make mistakes this way for sure. And actually, oops. And then now just return basis area plus left right area plus top down area, and let's give it a spin. Give it a spin, and hopefully this is right. Oh no, what did I get wrong? Why did I get the second one wrong? How did I get the third one correct but the second one wrong? Where did I? Oh, I was wrong about the base area. That's why I was wrong. The reason, that's a wow. I would have, I mean, because the thing with the donut is that there's nothing there, so it doesn't count as a surface area. So here, maybe we have to do something like, okay, the basis area here is fine. You could do it in either way, but if grid of IJ is equal to 0, basis area subtract by 2, one for the top base and the bottom base. Wow, I actually did miss that case because I was just like, oh, yeah, but thing, just all times 2, all times 2. All right, let's give it a quick submit. Hopefully this is good and there's no weird edge cases. And yes, and this is going to be linear time, constant space. You can probably see that is linear time just by, we look at each cell 3 times, 1, 2, and 3, and then for space we just have like 5 variables or something, right? 1, 2, 3, 4, 5 or something, and maybe a little bit more if you want to say auxiliary variables, but still constant amount. So yeah, cool. That's all I have with this one. It's kind of, I think this is a trickier easy than usual, even though conceptually everyone has the tools to do it. It seems like a fun problem. I don't know if it's an interview problem. A lot of downvotes. I don't think it's that bad. I mean, maybe it's probably not a great interview question, but it is a very standard competitive problem, I imagine. Like, I haven't seen it before, but these sorts of problems, right? These sorts of thing that gets you thinking, it's about that type. So yeah. That's all I have for this one. That's all I have for today. Let me know what you think. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.